Good morning, students. In this class, I am going to teach you about Poisson bracket. This Poisson bracket represented by the letter F and G. Poisson bracket represented by the letter F and G. This F is a function of position coordinate qi, momentum coordinate pi and t. This f is depend upon the generalized position coordinate qi, momentum coordinate pi and time t. Similarly, this g, it is the function of qi, pi and t. So this g also will depends upon the generalized coordinate, position coordinate qi, momentum coordinate pi and t. So both f and g will depend upon the generalized position coordinates qi, pi, momentum coordinate pi and time t. The Poisson bracket is defined as mathematically the Poisson bracket of f and g is defined as, this should be right like this, inside a bracket f comma g, that is equal to, it depends upon q and p, is equal to summation of I dou f by dou qi dou g by dou pi minus dou f by dou pi into dou g by dou qi. So a Poisson bracket of f and g is written as bracket f comma g suffix q comma p, that is it depends upon q and p, will be equal to summation of I. First you differentiate, partially differentiate this f with respect to q and this g with respect to p, and then this f with respect to p and this g with respect to q. Therefore what will happen? Summation of I, that is equal to summation of I into dou f by dou qi dou g by dou pi minus dou f by dou pi dou g by dou qi. You just see this, here dou qi, here dou pi, here dou pi, the next term is dou qi. This equation is called Poisson bracket of f and g. In general, it is represented as, in general, you may cut this q and p also, but it depends upon q and p, but it is not necessary to write this q and p in the suffix. So here you see I, not suffix, in this subscript. Okay, now this equation may be dou f by dou qi dou g by dou pi minus dou f by dou pi dou g by dou qi. This is equation number 1. So in general, this Poisson bracket of f and g is written as summation of I dou f by dou qi dou g by dou pi minus dou f by dou pi dou g by dou qi. But we know that function f is equal to function of qi, pi and t. This we already read in the previous chapters. So f is equal to f of qi, pi and t. Now differentiate 2 with respect to t. Now differentiate the above equation 2 with respect to t. What will come? You see df by dt, that is equal to summation I first dou f by dou qi, we already saw these things. Then dqi by dt plus what will happen next term? Dou f by dou pi dpi by dt plus dou f by dou t into dt by dt. These things we already saw in the earlier all topics. We saw how to differentiate with respect to time t. We know these things. That is first dou f by dou qi into dq by dqi by dt plus dou f by dou pi dpi by dt plus dou f by dou t into dt by dt. Then what will happen? These things df by dt, that is equal to summation of I dou f by dou qi, dqi by dt is nothing but qi dot plus dou f by dou pi by dou t is nothing but pi dot plus dt by dt is 1, so remaining term is dou f by dou t. Okay, so this is equation number 3. You keep it as equation number 3. So df by dt, that is equal to summation of I dou f by dou qi into qi dot plus dou f by dou pi into dpi, the dpi by dt is nothing but pi dot plus dou f by dou t. This is equation number 3. Now substitute the value of qi dot and pi dot from canonical transformation equations. We already derived the equations. We know according to Hamilton equation of motion or canonical transformation equation. So according to canonical transformation equation, we already saw in the earlier topic. So what it is? Qi dot, that is equal to dou h by dou pi. You just refer that video and you will understand, or you having these notes, then you saw this. So qi dot, that is equal to dou h by dou pi, and pi dot is equal to minus dou h by dou qi. Now substitute these values of qi dot and pi dot in equation 3. Okay, so what it will come? So equation 3 becomes df by dt, that is equal to summation of I dou f by dou qi. Instead of qi dot, you substitute dou h by dou pi minus or plus dou f by dou pi. Instead of pi, you substitute this minus dou h by dou qi here plus dou f by dou t. Okay, now what will happen? df by dt, that is equal to summation of I, this is dou f by dou qi into dou h by dou pi minus dou f by dou pi into dou h by dou qi plus dou f by dou t. Make it equation number 5. Now you see df by dt, that is equal to summation of I dou f by dou qi dou h by dou pi minus dou f by dou pi dou h by dou qi. Now you refer the equation 1. You refer the equation 1. That is equation, what is the equation 1? Poisson bracket of f comma g, that is equal to summation of I dou f by dou qi dou g by dou pi minus dou f by dou pi dou g by dou qi. Here you see, instead of the place g, here h is coming. You just refer the equation 1 and you will understand. So instead of g, here h is coming. Therefore this equation may be written as df by dt, that is equal to, instead of all these things, it is similar as f comma h plus dou f by dou t. Are you understand now? Instead of, in the first equation 1, instead of the g, here you see in the fifth equation, it is instead of g here coming h. Therefore there we are writing f comma g, Poisson bracket of f comma g in equation 1. But here we may write the same rule. Therefore this equation may be written as f comma h plus dou f by dou t. Understand? Right. This is equation number 6. So df by dt, that is equal to Poisson bracket of f comma h plus dou f by dou t. By seeing this equation 6, if f becomes a constant of motion, f is a function, we know f is a function, it depends upon qi, pi and t. This function f will become constant when the differentiation of that constant will become 0. That is, df by dt will become 0. Then this function f will become constant. Okay, understand? So when f is constant, that is the function f is a constant, then df by dt is equal to 0. df by dt is equal to 0. We know differentiation of a constant is 0. So df by dt will become 0. Therefore equation 6, what will happen? Bracket, Poisson bracket of f comma h plus dou f by dou t equal to 0. This is equation number 7. If the function f does not depend on time, then dou f by dou t will become 0. Understand? Are you understand this physics concept? When f is a constant, then differentiation of that constant df by dt will become 0. Therefore the equation becomes Poisson bracket of f comma h plus dou f by dou t is equal to 0. If f is not depends upon the time, it does not depends upon the time, then this term will depend upon the time. Therefore dou f by dou t will become 0. Or from the equation 7, Poisson bracket of f comma h becomes 0. Understand? So from equation 7, when dou f by dou t will become 0, then f of h will become 0. From this, we conclude that when a function whose Poisson bracket with the Hamiltonian h vanishes, then that function is a constant of motion. From this equation, we understand that when a function whose Poisson bracket with the Hamiltonian h vanishes, that is becomes 0, this function is a constant of motion. Thus, that function will represent a constant of motion. This is we inferring from Poisson bracket. That is, hence, a function whose Poisson bracket with the Hamiltonian is vanishes, then that function is a constant of motion. Constant of motion. So, a function whose Poisson bracket with the Hamiltonian h vanishes, then that function is a constant of motion. So, these are the things we inferring from Poisson bracket. Okay. So, in the next class, what are the main properties of Poisson bracket? That is, how canonical transformation equation and Poisson bracket are related to each other. So, in the next class, we will see Poisson bracket and canonical transformation equation relation. Okay. Okay, we will meet you in the next class.